So in the end of our last video, we said if we pull on this pulley with 24 feet of rope, that our weight will only raise up 3 feet. And that's a little weird to think about, to pull 24 feet and only get something to lift up 3 feet. And so I wanted to make a quick video explaining how that works, how that happens. And so if you look at this total distance effort, what you'll see is this distance effort we're pulling on this entire compound machine is also the amount of rope we are pulling through this very first pulley here, or the distance effort of machine 1. And we already know that we have an IMA of 2 for machine 1, and we know that the IMA for machine 1 is equal to DE over DR, and we can say that that's the DE of machine 1 and the DR of machine 1, and we just said that the distance effort for machine 1 is 24 feet. So let's think about that for a second. What would the distance resistance have to be? How far would this pulley have to lift up to get us an IMA of 2? Well, that would be half of it. That would be 12 feet. 24 divided by 12 is 2, so this pulley has to lift up 12 feet. And that is the distance resistance of machine 1, but it's also the distance effort of machine 2. It's how far machine 2 will raise. It's how much rope the first pulley will pull up. And so we can say that the distance effort for machine 2 is 12 feet. And then we'd have to ask ourselves, well, what would the distance resistance have to be for machine 2 to get us an IMA of 2? And that would, of course, be 6 feet, because 12 divided by 6 is 2. And so we know that machine 2 will raise up 6 feet. And then we can apply that same logic to machine 3. We can say that 6 feet is the distance resistance for machine 2, but we can also set it equal to the distance effort for machine 3. So we could say the IMA of machine 3 is 2, and it's 6 feet divided by how far this weight at the end will actually lift. Well, in order to get 2, it has to be half of it, so it has to be 3 feet, because 6 divided by 3 is 2, which is why this weight only lifts up 3 feet, even though we pull up 24 feet. Because that's how mechanical advantage inherently works. You decrease the force by increasing the distance. And if you're still confused by this, I recommend you go back to our movable pulley lesson. But a quick summary, if you look at this rope here, it's divided into 2 strands. So if I pull 24 feet of rope up, that 24 feet of rope will be divided literally into 2 halves, or 12 feet. And so this side will go up 12 feet, and this side will go up 12 feet, for a grand total of 24 feet of rope. And that same will be true here. If I pull up 12 feet of rope here, then this side will go up 6 feet and this side will go up 6 feet, because again, this rope here for this pulley is divided into 2 equal strands. And of course, the same is true here. If I pull up 6 feet of rope, then this side will go up 3 feet and this side will go up to 3 feet, because again, this rope is divided into 2 equal strands.